welcome to Tomorrow Unveiled. Looking at this first week of July 2025, it really feels different.
It does, doesn't it?
Yeah, forget the usual small software tweaks. Our research team, they've dug into it, and what they found points to something, well, much bigger. They're calling it a quiet revolution, even a tangible turn.
A tangible turn, I like that. Because it's about AI getting physical, right? Moving beyond just code.
Exactly. We're talking about these huge strategic shifts,
Yeah.
totally new ways of thinking, and breakthroughs that are seriously going to change how you interact with tech, like every single day.
And that's really what we try to do here on Tomorrow Unveiled, isn't it? Our research team has been wading through everything this week, all the news, the papers, the announcements. And the focus really is on those corroborated insights, the stuff that kept popping up again and again across all the information they gathered. We want to give you the important bits, without you having to drown in all the noise.
Absolutely. Yeah, a shortcut to being clued in. And believe me, there's some fascinating stuff this week. We're going deep on, first, these major changes in the actual bones of AI, the infrastructure.
Yeah.
Then, some genuinely surprising new kinds of AI that are like stretching the limits of what we thought possible. And naturally, we have to look at the challenges, because this much speed, it brings, the complexities.
Of course does.
Get ready, because we're talking discoveries blurring biology and computers and hardware stuff that's going to make your phone feel ancient soon.
Okay, let's unpack this then. This quiet revolution. What does it actually mean for AI? Why this label tangible turn?
Right. So the first big theme our research team flagged is this major pivot. AI isn't just about the algorithms anymore. It's shifting focus hard towards the fundamental physical stuff underneath it all, the infrastructure.
Yeah, what's really fascinating here, and the research bears this out, is the move away from being purely model-centric, where everyone was obsessed only with tweaking the algorithm.
Right. Better models, smarter models.
Exactly. Now it's becoming much more infrastructure-centric. And the sheer scale, the scale of the investments being made now in the foundations, it's staggering. It really signals a new phase.
Like what kind of scale are we talking about?
Well, we'll take the OpenAI partnership with Oracle. Just announced, July 2nd, 3rd?
Yeah, I saw headlines on that.
The research team highlighted this. It's reportedly a $30+ billion annual cloud computing deal.
Wait, 30 billion a year?
Per year. That's not just a big number. It's genuinely one of the largest single cloud contracts ever. It's fundamentally redrawing the map for AI infrastructure.
Okay, 30 billion a year. That's more than just buying servers. That sounds like a massive strategic play. What are the implications? Does this lock things up, create new dependencies?
That's the key question, isn't it? The deal involves securing, get this, 4.5 gigawatts of data center capacity.
Wow.
Spread across multiple U.S. locations. They're massively expanding Oracle's site in Abilene, Texas, nearly doubling it from 1.2 gigawatts to 2 gigawatts. Plus new sites planned in Michigan, Wisconsin, Wyoming, New Mexico, all over, Georgia, Ohio, Pennsylvania too.
You can almost feel the construction crews firing up.
Pretty much. And the strategic angle, as our team sees it, is clear. This shows OpenAI really pushing to lessen its reliance on, say, Microsoft Azure. It's about establishing its own computational sovereignty, independence.
Right.
It's a whole new competitive game where the big AI players are now chasing infrastructure control as a core advantage.
Okay, so this isn't just CEO shaking hands on big deals. This kind of foundational stuff.
Yeah.
It has ripples, right? How does this actually, filter down to us, to our everyday tech experience?
Exactly. It's not abstract at all. This infrastructure, it's the bedrock. It's what all future AI applications are going to be built on. So it directly impacts the kinds of cloud services that become available, how fast AI develops globally, how quickly new features roll out. Think about an AI breakthrough. How fast does it go from a lab idea to something useful on your phone?
This infrastructure sets that speed limit.
Precisely. It's the hidden engine driving that next wave of AI capabilities.
And here's where it gets really interesting, I think. How this push for foundational power, it isn't just staying in these giant remote data centers.
No, not at all.
Our research shows this tangible turn is bringing advanced AI much closer, right onto the devices you carry around.
Yeah.
How is this power shift changing our gadgets?
Yeah, if we connect the dots here, these hardware advances are absolutely crucial. They're the enablers for the next generation of AI experiences, the ones that will really change your daily routines.
Okay, like what? What did the research team pinpoint?
Our team looked closely at two key announcements this past week. First up, there's this thing called the Enavix AI-1 battery.
AI-1, so a battery specifically for AI.
Explicitly designed for it. For AI-enabled smartphones, wearables, other consumer gadgets. The core tech is pretty cool. It uses a 100% silicon anode.
Okay. What does it mean in practical terms?
Well, theoretically, silicon can store way more lithium ions than the graphite used in today's batteries, like 10 times more.
Whoa.
The breakthrough spec they're claiming is a volumetric energy density over 900 watt-hours per liter.
Which is good.
It's really good. It's like 30–40% higher than the best commercial batteries you can get right now.
Okay, so significantly longer battery life, even if the AI is working hard. That's a big deal for users. But does it unlock anything fundamentally new besides just lasting longer?
That's a great point. The first production samples are hitting 7,350 milliamp capacity. That's roughly double what you find in current top-tier phones.
Double, okay.
Plus, it charges super fast, 50% in just 15 minutes, apparently, and it lasts over 900 charge cycles.
Impressive.
So what it unlocks is overcoming that power bottleneck. Running those really demanding AI tasks right on your device, locally. Think real-time translation without needing the cloud. Or crazy computational photography effects running constantly, all day long.
Without killing your battery by lunchtime.
Exactly. True, all day on-device AI becomes feasible.
That definitely sounds like a tangible turn for phones. What about our desktops, our laptops? Are they getting this on-device AI boost too?
They are. On the computer side, our research confirmed details about Intel's next-gen desktop CPUs. Aerolake S, they're called, expected later this year.
Right.
These chips will have a new NPU that's a neural processing unit called NPU4, and it's rated for 48 TOPS.
TOPS.
Trillions of operations per second. It's a measure of AI-specific performance. And 48 TOPS comfortably beats Microsoft's requirement for what they call a Copilot Plus AI PC, which is 40 TOPS.
Ah, okay. So more than enough grunt for those built-in Windows AI features.
Precisely. It means sophisticated, always-on AI features won't just be cloud-dependent things or restricted to niche hardware. They'll be native, right there on your desktop.
So putting it together, these hardware breakthroughs mean the advanced AI we've mostly experienced through the cloud, or maybe on super high-end specialized gear, is actually coming to our everyday devices.
Yep.
Which brings real benefits.
Right.
Better privacy if the data stays local, faster responses because there's no network lag, more personalized experiences. It sounds like a fundamental shift in how we'll interact with tech daily.
It really is. Your personal devices running serious AI locally, your phone handling instant translation, your laptop managing complex creative tasks almost instantly. That's the transformation we're seeing unfold right now.
If you're finding this insightful, just a quick reminder, please take a moment to like this video, subscribe to Tomorrow Unveiled, and definitely hit that notifications bell so you don't miss any future updates. Okay, so we've talked about the massive investment in the foundations, the infrastructure, and the hardware getting supercharged. But our deep dive this week also uncovered another really powerful trend. It's the rise of these new kinds of AI breakthroughs. But they're not aiming for that single, godlike, artificial general intelligence, or AGI, that everyone used to talk about.
Right, the focus seems to be shifting.
Yeah, these are highly specialized AIs, designed to solve very specific, tangible problems.
Which raises a really important question. What does this future of specialized AI actually look like in practice?
Good question. What did the team find?
Well, the research team's findings really underscore this trend. Highly specialized systems tackling concrete, often physical world problems. And one of the most, frankly, mind-bending examples from this past week, which showed up across multiple sources, is something called Proteus.
Proteus. Okay, sounds fancy.
It stands for protein evolution, using selection, developed by scientists in Australia.
Protein evolution. Inside cells. What on earth does that mean for the real world? This sounds incredibly futuristic.
It kind of is. It's described as a biological artificial intelligence.
Biological AI.
Yeah, so instead of software on silicon, Proteus actually works inside living mammalian cells. It designs and evolves brand new molecules directly within the cell.
Wow.
It essentially mimics natural selection but speeds it up dramatically, so it can rapidly evolve, say, better proteins for delivering drugs, or even nanobodies designed to detect specific things, like DNA damage, a key marker for cancer.
Wow. Okay. That's blurring lines.
Definitely. And our research team noted it's open source, which is significant. It suggests potential applications in things like CRISPR gene editing or developing new mRNA medicines much faster. Imagine the acceleration in medical discovery.
That's incredible potential.
Yeah.
What else did the research uncover on this specialized AI front? Any other areas seeing big leaps?
Yes, another fascinating one was a big step forward in quantum computing for optimization problems.
Quantum. Still feels a bit out there for most people.
Well, this development might make it more practical sooner. A research group in China developed a new quantum search algorithm, a fixed point one.
Cool. Why is that significant?
Its big advantage is achieving that famous quantum quadratic speedup for search problems, but, and this is key, in continuous infinite domains.
Continuous domains, meaning not just like searching a list of names.
Exactly. Previous quantum search algorithms were mostly limited to discrete data, like items in a database. This new one is suited for complex, real-world problems with infinite possibilities. Things like engineering design optimization, complex financial modeling, or simulating physics problems.
So tackling messier, more continuous real-world challenges much faster.
Precisely. And interestingly, our team noted it uses photonic quantum circuits based on light, which could offer advantages in terms of scaling up and being more energy efficient compared to some other quantum hardware approaches.
Okay, so it's not just about what AI can do, but how efficiently it tackles these really hard, complex problems. Any other tangible applications popping up this week that caught the team's eye?
Oh, definitely. On the health front, Isomorphic Labs, that's Alphabet's AI drug discovery company, well, they're apparently getting ready to start human trials for their very first AI-designed drug compounds.
Human trials already, that feels fast.
It is fast. It's seen as a major validation point for this whole AI-native approach to drug discovery. Using AI, like their AlphaFold for protein structures, to predict targets and design drug candidates way faster than traditional methods could potentially shave years off the process.
Huge implications for medicine.
Absolutely. And the team also found great examples in climate and materials science. For instance, one project used AI to develop a new kind of eco-friendly paint formulation.
Paint.
Yeah, but paint designed to significantly cool buildings. It reflects sunlight so well it could cut energy used for air conditioning by up to 30% in some cases.
Wow. Simple, but potentially massive impact.
Right. And another big one, the European Center for Medium-Range Weather Forecasts, ECMWF, they just officially switched on their new AI-based forecasting system.
AI for weather forecasting. How's it doing?
Extremely well, apparently. The reports show accuracy gains up to 20% for key things like surface temperature. And here's the kicker. It's apparently 10 times faster to run and uses about 1,000 times less energy than their older, traditional supercomputer models.
10 times faster and 1,000 times less energy. That's transformative for efficiency in providing critical services.
It really is. And even governments are getting in on the act. Our research flagged the UK's Extract tool.
Extract.
It's an AI system designed to automatically read and digitize old handwritten planning documents and maps. The goal is to speed up processing for housing developments, potentially helping unlock permissions for up to 1.5 million new homes by clearing planning backlogs.
So using AI to tackle bureaucratic bottlenecks.
Exactly. All these examples, they really drive home the point. AI isn't just theory or lab experiments anymore. It's moving rapidly into real-world use, solving tough problems in health, sustainability, public services, problems that were maybe too complex or slow to tackle before.
Okay, the pace of advancement is clearly, well, breathtaking. But rapid progress always brings, let's call them growing pains, complexities, risks.
Always.
So pulling back a bit, what does this all mean for the bigger picture, for the landscape of AI and the, frankly, critical challenges we need to figure out as a society?
Well, what's really fascinating and maybe a little worrying is this collision you see happening. The research team highlighted this clash of different speeds. You've got the tech developing exponentially.
Like super fast.
Then you have corporations adopting it, maybe more linearly, figuring out business models.
Slower, but still moving.
And then you have the legal and regulatory systems kind of lagging behind, trying to catch up. This mismatch in pace creates a lot of volatility, a lot of uncertainty.
Makes sense. Any specific examples of that friction this week?
Yeah, one really interesting ethical discussion surfaced around an AI model from Helmholtz Munich called Centaur.
Centaur, what does it do?
It's designed to simulate human decision-making, and the research indicates it does this with, quote, startling accuracy. It was trained on a massive data set, 10.6 million choices from 60,000 people.
Startling accuracy in predicting human choices.
Right.
Wow, that sounds useful, maybe a bit creepy. But then you mentioned superhuman abilities. Where does that fit in? How
Yeah.
could it be accurate and superhuman? And why does that matter for things like, say, mental health?
That's precisely the ethical tightrope, isn't it?
Hmm.
So while it's highly predictive of group behavior, Centaur also shows these superhuman traits. Like it can recall 256 digits instantly, humans average about 7, or it has a reaction time of 1 millisecond, which is physically impossible for us.
Okay, so it's not really thinking like a human, even if it predicts outcomes well.
Exactly. It suggests it's not truly replicating the underlying human cognitive processes or our biological limits. And the risk, which our research team flagged, is mistaking this high-fidelity simulation for genuine replication, especially if you start using it for high-stakes things.
Like diagnosing mental health conditions you mentioned.
Right, or using it to inform social policy. If the model makes correct predictions but doesn't understand the human why or the context of the constraints, relying on it could lead you down some dangerous paths. It might miss nuances critical to human reality.
That's a subtle but really crucial distinction. And it feels like the rules and regulations are scrambling to deal with these kinds of nuances, right? You mentioned that pace collision.
Absolutely scrambling. The past week really threw that into sharp relief. We saw this global trend towards, well, fragmentation in how AI is governed.
How so?
Well, the UK announced it's postponing its big comprehensive AI law by at least a year, signaling maybe a more hands-off, let's wait and see approach, which is a stark contrast to the European Union. Their landmark AI Act is moving full steam ahead, with some key compliance deadlines for general-purpose AI hitting in August 2025. Very different philosophies.
And the U.S.
In the U.S., federal action seems stalled. But get this. Our research noted that all 50 states introduced some kind of AI-related legislation just in 2025.
All 50? Wow, that sounds like chaos.
It creates a really messy, potentially contradictory patchwork of rules across the country. So you have this pace collision in full effect, exponential tech, linear corporate adoption, and these lagging, fragmented legal systems creates massive uncertainty for developers, businesses, everyone.
Yeah, hard to build something if the rules keep changing or differ everywhere. And beyond regulation, what about really fundamental legal questions? I think I saw something about a big copyright lawsuit starting.
Yes, that's another huge unresolved issue hanging over the entire generative AI field. The Getty Images versus Stability AI trial kicked off in the UK High Court this week.
The image generation case?
Exactly. This is a pivotal one. It directly asks the question, does training an AI model on billions of images scraped from the internet, many of them copyrighted, actually constitute copyright infringement?
The core training data issue.
Right. The outcome here could have massive implications. It could force generative AI companies to completely rethink how they get their training data, how they build their models. The whole foundation could be shaken.
So the very legality of how some major models were built is up in the air. That's huge uncertainty.
It really is. And circling back to the infrastructure piece, that OpenAI Oracle deal, while it solves compute needs, it also, as our team noted, potentially creates new systemic risks.
Like what?
Concentration of critical compute power in fewer hands. Plus, it fuels a geopolitical dimension, the competition for resources, and for talent. We saw reports this week of Meta aggressively poaching top AI researchers from OpenAI for their new superintelligence group. It's a real talent war heating up.
Competition driving up costs and maybe concentrating power.
Could be. And even with the quantum AI stuff we mentioned, the potential is there. But scaling those systems, managing errors, those are still huge hurdles. And there are ethical questions, too, about who gets access to this powerful tech. Could it just widen existing inequalities if we're not careful?
A lot to think about there. We certainly covered a ton of ground today, these huge infrastructure plays, the rise of specialized AI solving real problems, and these significant complex challenges bubbling up. We really hope you're finding this deep dive insightful. And hey, if you're listening on a service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could take a second to leave Tomorrow Unveiled a rating and a review. It honestly makes a big difference in helping new listeners discover us.
So if we try to synthesize all this, pull together the signals from this really pivotal week, what does it tell us about where AI is heading?
Yeah, what are the big takeaways?
Well, first, that tangible turn feels very real. AI is clearly moving beyond the abstract cloud. It's embedding itself in physical devices, in materials, even, remarkably, in biological systems.
From bits to atoms, almost.
Kinda, yeah. Second, the rise of the specialist seems undeniable. The future looks less like one giant AGI and more like a collaboration of expert AIs, each tackling high-value, specific problems.
Okay.
And third, what our research really highlighted is the primacy of unseen enablers. Things like the massive data sets, the experimental platforms like Proteus, the advanced hardware like new batteries and MPUs. These foundational elements are becoming just as critical, maybe even more critical than the algorithms themselves right now.
Those are really strong takeaways. Infrastructure, specialization, and the enabling tech. It really makes you think. This rapid physical integration of AI, combined with its growing specialization, alongside this messy, fragmented regulatory picture, how is that going to reshape not just industries, but our actual daily lives, our global power structures? And what new ethical questions pop up when AI gets this deeply embedded? Especially with those superhuman capabilities we touched on with Centaur. What happens when a machine can predict our collective choices with startling accuracy, or perform tasks far beyond our biological limits? Where does that leave human agency and understanding?
Lots to ponder there.
You're definitely food for thought. We'd love to hear what you think. Whether you're watching on YouTube or listening on your favorite podcast app, please drop a comment and let us know your thoughts on AI Unveiled this week in AI News. Thank you so much for joining us on Tomorrow Unveiled.
Thanks, everyone.
We look forward to exploring the future with you again next time.